Discuss the topic on that is polynomials. This is 10th math CBSE topic. So we know the polynomial. So if you remember in the previous year, that is in the 9th standard, you can define the single variable polynomial. What is meant by the single variable polynomial? You can see like this: ax plus b equal to 0. This is a polynomial with variable x. Now we can define the order of the polynomial. What is the order of the polynomial? It purely depends on the power of the variable x. If you observe here, the power of the polynomial is a into x power 1 plus b. So that means this is a polynomial with the degree we can say this is with the degree 1, and further we can say this is a first order polynomial. And moreover, the nature of this polynomial is linear. The nature of the polynomial is linear. And now if we increase the order of the variable presented in the expression, let us say this is our equation, that is ax plus b equal to 0. This is an equation. Suppose if the order of the variable rises to 2, that is if we have ax square plus bx plus c, let us say this is a polynomial of order 2. This time the variable x is having a highest power of 2. The condition is the highest power of the variable x square and its coefficient. What is the coefficient of x square? The coefficient of x square is a. So which should not be 0. Then we will call it as a second order polynomial. So let us go back to the first order polynomial. To confirm that it is a first order polynomial, in this case the coefficient of x is a, which should not be equal to 0. So do remember, the order of the polynomial is judged or verified based on the highest power of the variable and its coefficient. Its coefficient should not be equal to 0. That is a is the coefficient of x which is not equals to 0. Then we will say that it is first order polynomial. If it is ax square plus bx plus c, the coefficient of x square is again a, which is not equal to 0. Then we will call it as a second order polynomial. This is a brief idea about the polynomial. That means it is an equation or expression which is represented in terms of a variable and its coefficients. So what are the coefficients here? A is the coefficient. So what is a here? A is the coefficient. And if you ask me what is the status of b? B is a constant. The status of b is it is a constant here. B is a constant here. So similarly, we can construct the polynomial of any order. Let us briefly look at the third order polynomial. The third order polynomial, which is represented as, let us say ax cube plus bx square plus cx plus d, let us say equals to 0. Now what is the order of the polynomial? This is the order of 3. The order of the polynomial is 3. How can we say that it is a polynomial with order 3? because the highest power of the variable. So what is the variable here? What is the variable here? Variable is x. Variable is x and its coefficient. And its coefficient. What is the coefficient of x cube? It is a. A is here coefficient. A is coefficient. Again, we need to remember the condition. What is the condition? A should not be equal to 0. It is very, very important. Only then it becomes a polynomial of order 3. Suppose you ask the question, what happens if the coefficient of x cube a is 0? What happens if the coefficient of x cube is 0? Then it will become a polynomial of order 2. It will become a polynomial of order 2. So because the variable is x and which is having a highest power of 2, its coefficient is b, right? So this is a general idea of the polynomial. Two things we need to remember while representing or while understanding the nature of the polynomial. So one should look at the highest power of the variable. One should look at the highest power of the variable and its coefficient. And its coefficient should not be equal to 0. The coefficient should not be equal to 0. Based on that, one can conclude that the order of the polynomial or degree of the polynomial, the order of the polynomial or degree of the polynomial, both are interchangeable. So if you have any expression, if you have any polynomial equation, we can say that its order or degree, both are same. So for instance here, so let us say a is not equal to 0. Let us consider the same expression, ax cube plus bx square plus cx plus d equal to 0. So in this case, the order of the polynomial or degree which is 3. The order of the polynomial or degree of the polynomial is 3 here, right? So now one important aspect of the polynomial is its roots. Its roots are zeros. So let us take a simple linear equation. Let us take a simple linear equation. Let us say the simple linear equation. Let us say y equals to 2x plus 3. Y equals to 2x plus 3. Right. This time we are constructing the polynomial with variables 2. There are 2 variables here. Right. So still if you have any confusion, we will go back to this and we will rewrite this expression as. So before we discuss the polynomial with the 2 variables, let us go more deeper into the single variable polynomial. Let us go more deeper into the single variable polynomial. So here this is a polynomial of order 1 because 2x power 1 plus 3 equals to 0, right? Now one important aspect of this equation is finding the zeros. Finding the zeros or roots. Finding the zeros or roots of the expression or equation. So how to determine the zeros? How to determine the zeros? So one should have a clear idea what is meant by a zero or what is meant by a root here. So zero means if you substitute, let us say this as some expression f of x. I will call it as f of x. I will define this one as f of x equals to 2x plus 3. F of x equals 2x plus 3. So we want to determine the zeros of this equation. This is the point to be remembered. Where does the polynomial expression or equation becomes 0? Where does the polynomial becomes 0? At what value of the variable? At what value of the variable? So what we can guess? Let us say if I take x equal to 1. If I take x equal to 1, what will happen? This will become f of 1. Will it become 0? Will it become 0? We can say that it is 2 into 1 plus 3. So what we can get? That is 2 plus 3, which is 5. So which is not equal to 0, which means 1 is not 0. 1 is not 0 or the root of this expression. Similarly, let us take one more value, that is f of minus 1. Let us take f of minus 1. So what is the value of this expression at x equals to minus 1? So what is the meaning of this f of minus 1? So what here it is at x equals to 1. At x equals to 1 we are evaluating the value of this 2x plus 3 expression. Now at x equals to minus 1. At x equals to minus 1 we are evaluating the value of this function or the polynomial. So what is it? 2 into minus 1 plus 3. So what is the value we can get here? What is the value we can obtain? So this is minus 2 plus 3. This is again 1. 1 not equal to 0. Not equal to 0. So which means minus 1 is also not a root or 0 of this polynomial or the function. Right? Like this you can go further. Substitute x equal to 2, x equal to minus 2. Okay, now can I have the value of x? Can I have the value of f of x at x equal to 0? So let us say at x equal to 0. At x equal to 0. What is the value of f of x? That means f of 0. F of 0. What is f of 0 now? 2 into 0 plus 3. Will it be a 0? Will it be 0? Will it be whether the function becomes 0? Will the function becomes 0 when we substitute x equal to 0? No, because f of 0 becomes, it is 3 and is not equal to 0. It is 3 and is not equal to 0. So what we can confirm? Still 0 is not a, the numerical value 0 is not a root or 0 of this expression f of x. Right? Now we have a simple representation how to determine the 0 or root of the expression. So what is it? So what is that value? How to find this value? How to find this expression? So let us say like this you can continuously determine. Like this you can continuously determine. The point is at which value of x, at which value of the variable the function f of x becomes 0. Now how to determine that value? Directly you substitute, you make it to 0. You equate the function to 0. So what I am going to have here, that is 2x plus 3 is equal to 0, which means 2x is equals to minus 3. Therefore x equals to minus 3 by 2. X equal to minus 3 by 2. Now what is our observation? What is our idea here? Minus 3 by 2 is the 0. Minus 3 by 2 is 0 or root of this function f of x. Right? So this is how one can determine the zeros of the polynomial, or the function f of x. So since we are considering it's a first order expression, similarly we can evaluate the zeros of the polynomial of order 2, the zeros of the polynomial of order 3. So what is the idea of 0? What is the term 0 represents? What is the term 0 represents here? That is the value at which. So now we can define the important aspect of the polynomial. What is that important aspect? The value at which, or the values at which the function, let us say f of x, becomes 0. The values at which the function f of x becomes 0, which we call it as the zeros. The value, it can be a single value or it can be a more than one value. There could be 2 values or 3 values or only one value at a time. Right? So this concept is very, very important and essential for the topic polynomials. Right? This is a key idea. So in the polynomial, the topic, in the topic polynomial, one thing is you need to analyze the order. Also you need to determine the roots or zeros of the polynomial, right? So today we stop here. This is just a basic demo kind of thing, and in the next class, that is tomorrow, we will explore further. Thank you.